For all of human history, we could only gaze up at the night sky and wonder, are we alone in this vast cosmos? The recent discovery of thousands of planets beyond our solar system has brought us one step closer to answering this profound question that has puzzled philosophers for millennia. Before we dig deeper, please do subscribe to Septic Cosmos. Now let's get right to it. In the past 3 decades, thanks to advanced telescopes and clever detection techniques, we have discovered over 5,000 exoplanets, alien worlds orbiting distant stars light years away. In the early 1990s, we could only find massive gas giants, larger than Jupiter, and completely inhospitable to life as we know it. But as technology rapidly improved, smaller, rocky, and more Earth-like planets began emerging. To date, we have confirmed over 50 exoplanets with masses similar to our home planet Earth, and we've discovered over 800 additional worlds less than 1.5 times the size of our planet. This is an astounding accomplishment, considering the very first exoplanet was only detected in 1992. Still, finding potentially habitable true Earth twins remains difficult, but new revelations point to tens of billions of promising worlds across our Milky Way galaxy. One exciting nearby system is Gliese 667, located just 23 light-years away in the constellation Scorpius. This triple star system contains at least 6 planets orbiting Gliese 667c, an M-type red dwarf less than half the size of our Sun. At least 3 of these worlds are considered super-Earths, with sizes between Earth and Neptune orbiting within the habitable zone, that sweet spot where temperatures allow liquid water to exist on the surface. Super-Earths are defined as having masses between 10 times that of Earth. They are primarily made of rock with likely thick atmospheres compared to our own planet. Gliese 667cb, the largest at over 5 times Earth's mass, orbits too close to its faint star to be habitable. However, the next planet in, Gliese 667cc, shows incredible potential. Slightly larger at almost 4 times Earth's mass, Gliese 667cc orbits at the inner edge of the habitable zone, completing 1 lap around its parent star in just 28 days. Being tidally locked, it likely possesses a much thicker atmosphere than Earth, which helps distribute heat evenly around the planet. Though the perpetual daylight side may be scorching hot, the night side could host average mild temperatures, thanks to the dense atmosphere's ability to transfer warmth. Gliese 667cc's parent star, 667c, is much smaller, cooler, and dimmer than our Sun, but Gliese 667cc orbits close enough to this faint red dwarf to receive nearly the same total amount of energy as the Earth gets from our bright Sun. However, the predominant light on 667cc is infrared rather than visible, resulting in perpetual dusk rather than daylight on its surface. Frequent flares and sunspots from the temperamental star may also disrupt conditions. The higher mass and tight orbit means Gliese 667cc likely has 60% stronger gravity and a much thicker atmosphere than Earth. While challenging, many organisms may adapt to this alien high-pressure, low-light environment. However, more concerning is how close it orbits to the volatile and flaring red dwarf. The frequent radiation bursts could strip away any atmosphere over time, leaving the planet dry, barren, and inhospitable. Luckily, 2 more potentially habitable worlds orbit farther out in the Gliese 667 system, beyond the reach of their star's deadly flares. Gliese 667ce and Gliese 667cef are nearly identical, both with about 2.7 times Earth's mass. In the cooler, more distant orbits, they avoid the volatile outbursts of their small but violent star. Thicker atmospheres would help regulate temperatures and allow liquid water to likely persist on their surfaces as well. Based on extensive calculations, the boundaries of the potentially habitable zone around the dim red dwarf Gliese 667c probably fall between 0.095 0.126 AU on the hot inner edge closest to the star, and 0.241, 0.251 AU on the freezing outer edge. Remarkably, 4 of the 6 known planets in this nearby system fall within or tantalizingly close to this circumstellar Goldilocks zone. Not too hot, not too cold, but just right for life to gain a foothold. Such compactly packed planetary systems circling tiny, dim red dwarfs seem to be very common, with several habitable zone planet candidates in each system. This makes sense when considering red dwarfs alone account for over 70% of all stars in our cosmic neighborhood. Therefore, conservatively, tens of billions of potentially habitable worlds likely exist just within our own Milky Way galaxy. Our chances for discovering life beyond Earth have never looked more promising. As we uncover more star systems similar to Gliese 667, some patterns are emerging. For example, the circumstellar habitable zone is much more compact and closer to the star compared to hotter, larger suns like our own. Multiple habitable zone planets per star also seem to be the norm rather than the exception for these cool red dwarf systems. And importantly, conditions on these worlds are unlikely to precisely match Earth. Challenges like tidal locking, diminished sunlight, heightened gravity, and frequent stellar flare bombardment provide environmental hurdles for the development and persistence of life as we know it. However, as extremophiles in some of Earth's harshest environments have demonstrated, life can adapt, evolve, and even thrive under the most unlikely cosmic conditions given sufficient time. The hunt continues for an elusive exo-Earth, a planet truly twin-like to our own world, but in the meantime, these alien Earth cousins offer our species the very first tangible peek at worlds beyond our home solar system that could harbor life beneath their alien skies. Planets like Gliese 667 CC, CE, and CF will likely always remain enigmatic and mysterious to us, as they only appear as dim, hard-to-see specks of light, even in our largest telescopes. But statistical studies of their orbits and thoughtful models of their interiors still paint a compelling picture of their potential to support life. Someday, in the not-so-distant future, next-generation telescopes may grant us the power to study the atmospheres and surfaces of these worlds across unfathomable distances and directly search for signs of life. Perhaps we will find conclusive evidence of extraterrestrial life through the spectrographic detection of methane, oxygen, or even artificial industrial pollutants in a planet's atmosphere. Until then, we can only speculate and imagine what wonderful secrets those distant planets similar to our own Earth are harboring out there in the vast, mostly unknown darkness of outer space. Beyond just the tantalizing possibility of life detection, cataloging and studying exoplanets greatly expands our understanding of how planetary systems form, evolve, and change over billions of years across the cosmos. We've already uncovered incredible diversity, including lava worlds with seas of molten rock, diamond planets, ocean planets, and even circumbinary planets orbiting two suns instead of one. Our cosmic perspective and sense of place in the grand universe grows exponentially with each new and alien world unveiled. The TRAPPIST-1 system highlights that we still have so much to learn. This single cool red dwarf star is host to at least 7 rocky planets, 3 of which orbit within the habitable zone. But the alien surfaces and atmospheres of the TRAPPIST-1 planets are so different and extreme compared to our solar system that traditional models fail to reliably predict their properties and potential habitability. Only through direct observation and scrutiny can we hope to unravel the mysteries of the TRAPPIST-1 worlds and determine if they are truly suitable for life. The incredible discovery of thousands of exoplanets in recent decades serves as a critical reminder that our Earth and even our place in the cosmos is far less central, unique, and significant than humans once arrogantly believed. Most stars, even trillions we cannot see, likely have worlds orbiting them, often many. Each new point of light unveiled out there reveals the true mind-boggling scale and wonder of creation, and the common miracle of planetary genesis flung across unimaginable gulfs of time and space. Subscribe to Septic Cosmos for more.